Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important question we are solving, that is from the uncertainty principle. Heisenberg uncertainty principle. It is a very important principle in our competitive examination. Without Heisenberg uncertainty principle, there is no question paper, whatever it may be. Any exam you have to write it is, there is a question from the Heisenberg uncertainty principle. Now you have to see. In CSIR December 2012, there was a question. If a particle is represented by the normalized wave function, one particle is represented, that particle wave function is normalized wave function, psi of x is equal to, what is that wave function? You have to see, psi of x is equal to root 15 into a square minus x square is divided by 4 into a to the power of 5 by 2, 4 into a to the power of 5 by 2 for, so this is the box length is the, you have to take it as a, that length is equal to minus a is less than x is less than plus a is there. These are the limit. So under the minus a to plus a, that wave function is existing square root of 15 a square minus x square 4 a to the power of 5 by 2. Otherwise you have to take it as a 0. Otherwise you able to take it as 0 means other than this, less than the minus a or greater than the plus a, you have to take, you able to get it as a 0. Otherwise you able to get the 0. Now what they want to ask, they are asking about the uncertainty in the momentum. So they are asking about uncertainty in the momentum, they are asking. What is the formula for the uncertainty in the momentum? So the formula for the uncertainty in the momentum is equal to delta p is equal to, they are asking, delta p is equal to square root of p square mean minus mean p whole square. This is the uncertainty relation, p square mean. So expectation value of p square minus expectation value of p whole square. This is the formula. First we need to calculate the expectation value of p is equal to, how much we need to calculate. First one, expectation value of p is equal to how much? So we know that the expectation value of p is equal to bra psi p ket psi. This is our expectation value of the p. But you know that p is equal to, what is the p? P is equal to minus I h cut into dou by dou x. For a one dimensional you have to write it is px. Our psi of x is equal to, our psi of x is equal to, what is the function? Root 15 into a square minus x square is divided by 4 into root 15 a square minus x square is divided by 4 into a to the power of 5 by 2, a to the power of 5 by 2. So for, so minus a is less than x is less than plus a. This is our wave function. Now we need to calculate the expectation value. How we have to calculate this expectation value? How to see the expectation value of p is equal to integral. So what is our limit? So lower limit is minus a, upper limit is plus a. Bra psi is equal to psi conjugate, you have to write it as root 15 is divided by 4 into a to the power of 5 by 2 into a square minus x square into, what is your p? Your p is equal to minus I h cut into dou by dou x, minus I h cut into dou by dou x. Again your ket psi is equal to root 15 is divided by 4 into a to the power of 5 by 2 a square minus x square into dx. This is the substitution in terms of the integral representation I have to write it is. So therefore ket p is equal to root 15 into root 15 15. So 4 into 4 is equal to 16 a to the power of 5 by 2 into a to the power of 5 by 2, a to the power of 5. So, integral minus a2 plus a square minus x square into, so we have to write it is minus I h cut, we have to represent as a, which one you have to write a square, you have to differentiate a square minus x square, you have to 0 minus 2x, you able to take 0 minus 2x into dx, you have to write it is clear. So, now you able to take 15 is divided by 16 into a to the power of 5, 16 into a to the power of 5. So, integral minus a2 plus a minus into minus plus I h cut into 2. So, you have to take it as a x, you have to multiply a square into x minus x cube into dx, we have to write it is clear. Now, you have to bring outside. So, what you have to bring outside? 2I h cut into 15 is divided by 16 a to the power of 5. 16 a to the power of 5 integral minus a2 plus a square into x minus x cube into dx. First, you have to see this function is odd function, this function also odd function. The total function you are getting as a odd function. These limits are which limits? Even limits. Now, you have to integrate and you will substitute. So, what you are going to get? This entire integration you are going to get it as a 0. 0 into something is equal to 0. So, therefore, what we have to write? The expectation value of p is equal to how much? The expectation value of p is equal to 0 we are finding. The expectation value of p is equal to 0. Now, we need to calculate the expectation value of p square, we have to calculate. So, how we able to calculate the expectation value of p square, you have to see. The expectation value of p square is equal to brass I p square ket psi, we have to write it is. So, therefore, brass I p square is equal to minus I h cut dou by dou x psi whole square into brass I, we have to write it is. So, therefore, we have to take it as a brass I. So, minus into minus plus I square is equal to minus h cut square into dou square by dou x square into ket psi, minus h cut square into dou square by dou x square into h cut, we have to write it is clear. Now, you have to substitute there. So, what we have to substitute? Minus h cut square you have to take outside. Integral minus a2 plus a brass I is equal to root 15 into a square minus x square is divided by 4 a to the power of 5 by 2. So, into dou square by dou x square into root 15 into a square minus x square is divided by 4 a to the power of 5 by 2 into dx. I am substituting the values. Now, you have to take the constant, you have to take outside. Minus h cut square I am taking outside. Root 15 into root 15, how much you are going to get? So, that is the 15. Root 15 into root 15 is equal to 15 is divided by 16 a to the power of 5. 16 a to the power of 5 integral minus a2 plus a square minus x square you have to keep here only. First, you have to differentiate. So, minus 2x you able to get it, minus 2x into, again you have to differentiate, you will get the minus 2 into dx, you are going to get it clear. Now, you have to write it is the expectation value of p square is equal to, the expectation value of p square is equal to minus h cut square is divided by 16 a to the power of 5 into, so integral, so minus into minus plus you have to take it as a, the 2 also you have to bring into that side, you able to write integral minus a2 plus a, you have to take it as a square minus x square into dx, you have to write it is clear. So, now you have to take So 2 1 ja, 2 8 ja. So h cut square into 15 is divided by, so 8a to the power of 5. So you have to take the integration. So a square into, so integral dx, you have to take it as a minus a to plus a minus integral minus a to plus a x square into dx, you have to substitute. So therefore 15 h cut square is divided by 8a to the power of 5 into, so you have to take it as a square, this is the a, it will come, a plus a is a 2a, so this one you able to get it as a 2a cube, you have to get. So this is the x cube is divided by 3, so therefore what you are going to get, so minus 2a cube is divided by 3 you are going to get. So what is you are going to get? So 2a cube is divided by 3 you have to going to get. So 2 1 ja, you have to take the 2 outside. So 2 4 ja, you have to get it. So therefore a cube also you have to take outside. So a square you are going to get it. So therefore 15 is divided by 4 h cut square is divided by a square into 1 minus 1 by 3. 1 minus 1 by 3 is equal to 2 by 3. So 3, so you have to get it as this is a 2 by 3, 3 1 ja, so 3 5 ja, so 2 1 ja, so 2 2 ja you are going to get. So 5 by 2 into h cut square is divided by a square you are going to get, which is equal to, so expectation value of p square is equal. But what we need to calculate? We want to calculate the uncertainty in the momentum. Delta p is equal to the square root of expectation value of p square minus expectation value of p whole square. So what is that value? How to see here? So 5 by 2 into h cut square is divided by a square. The expectation value of p is equal to 0. So therefore root 5 into h cut is divided by root 2 into a. This is the corresponding wave function uncertainty in the momentum. So what is your answer? Once you have to see, your answer is root 5 into h cut is divided by root 2 into a. So once you have to take option D is correct. Like this we have to do in our competitive examination. So not only that, then momentum in uncertainty, any uncertainty they want to ask, you have to substitute in this formula. First you calculate the expectation values. In the postulates of the quantum mechanics also we are learning the expectation value of the momentum, and so expectation value of any dynamical physically measurable quantity we have to discuss. Clear? Now once again we are informing, we started the CSIR and GATE physics online coaching mode. We have one app, that is Quantum Online Academy app. So we are giving the coaching to the DL and JL physics content we are going to give. So once you have to see, once you have to download our app and then see the courses, CSIR and GATE physics course will appear like this, JL physics course will appear like this, DL physics course will appear like this. Not only that, if you want to interested to take the individual course, maybe mathematical methods of physics, classical mechanics, electromagnetic theory, quantum mechanics, right now these 4 papers are available. If you want to take, you have to take the individual paper also. If you want to really crack the CSIR examination or really learn the physics subject, you approach me and you call me and you negotiate me. You have to take the CSIR and GATE physics content course. So that will help you, that will help you to stand in front of the podium to teach to your students. Thank you so much. Please share and subscribe and like our YouTube channel. Like these videos, where I will upload all CSIR content according to the content for each and every word, each and every sentence in the CSIR, what is that syllabus. One question I have to take and I will discuss in our YouTube channel also. You have to listen and enjoy through the YouTube channel also. Don't forget. So please share and subscribe and like the bell button also. Thank you so much.